Hi Trigoners! So today we're going to take some notes on section 1.3, absolute value and inequality. So here are our objectives. We're going to be able to simplify absolute value expressions, be able to solve absolute value equations and inequalities, be able to describe an absolute value inequality in words, and be able to solve radical inequalities. So we actually are going to do the radical inequalities in our next, so that would be notes 1.3 day 2. Okay, so let's get started here with the first part. We're going to talk about absolute value. So the absolute value of a number is its distance from 0 on the number line. And you could describe it in a piecewise function. Okay, that's kind of an interesting thing to do. So that if you are thinking of the graph of the line y equals x, the graph of the line y equals negative x, and we're saying that if the y is negative x for x values less than 0, and y equals x for values of x greater than or equal to 0. So again, you put this together, and here's your absolute value function. Also, we remember that, again, absolute value is, the y values are positive. So here goes. Let's think about how far apart are -2 and 18 on the number line. So if you draw a number line, go ahead and think about your answer. Okay, and I think a lot of you just say 20 right away, but let's just think about why. If you do 18 minus a -2, that's 20. And again, we want a positive value, so you could think of that with an absolute value. Let's go ahead and try -2 and x. Give it a try. Okay, so similar, do you see how you could say x minus 2? Because again, the distance between x and -2, you subtract. So it's the absolute value of x plus 2. Okay, so let's think about absolute value for a little bit. So if you think about this, x, the absolute value of x could be 3, or it could be less than 3, or it could be greater than 3. We have all bases covered here. So let's first of all think about what happens if you have an equation. If you have an absolute value of x is 3, so that means that x could be 3, or it could be -3. And it's because the distance between x and 0 on the number line. Okay, that's kind of messy. So x is 3 units from 0 on the number line. And that's how we have two answers of 3 and -3. Okay, so let's think about what that means if you have the absolute value of x is less than 3. So let's think about what that means visually. So this is saying x is less than 3 units from 0 on the number line. So you would say all of these values, right? X is less than 3 units from 0 on the number line. So x is between -3 and 3. So there are a few ways you could write this. Oops. Or you could also write x is less than 3 and x is greater than -3. So if it's a less than, it's an and some people write less than to help them remember that. Less than is an and. Okay, let's go ahead and do the next part. We have the absolute value of x is greater than 3. So again, let's think about what that means. Go ahead and pause the video and see if you could describe that in words. So we say x is more than 3 units from 0 on the number line. So here's 0. So we have x is more than. It's great. So when you have a greater than, and again, some people write it like this to remember, greater or greater than. If it's a greater than, it's an or. So I would say x is greater than 3 or x is less than -3. All right, let's go ahead and think about maybe some problems with some numbers. If you take a look at number 3 here, it says evaluate pi minus 5. So go ahead and pause the video. How would you rewrite that without an absolute value symbol? Okay, so did you realize that you could write it as 5 minus pi? Because pi is approximately 3.14, so 5 is a larger number, and again, the absolute value is positive. So if you wrote pi minus 5, that actually would be a negative number, and that's why it's 5 minus pi. Okay, let's go ahead and take a look at number 4. So what we're going to do now is we're going to write an absolute value equation or inequality from words. So let's do the first one together, and then you could pause the video and try the rest. So if I say x is more than 18 units from 7, so first of all, more than 18 units would be a greater than symbol. And again, I'm trying to figure out how far is x from 7. It's a distance, and that's why you would say x minus 7, because you would subtract if you're looking for a distance. So go ahead and pause the video and try B, C, and D. Give it a try. Okay, so let's see what you got for B. Notice it says x is at least 3 units from 10. So at least 3 would be greater than or equal to. And if x is from 10, that means how far is it from? So we're trying to find a distance, so you would subtract. Just like no greater than 10, so that would be less than. And how far is x from negative 15? So if you subtract, x minus a negative 15 is plus. So if I say x is at most b units from C, I'm trying to find out how far is x from C. So that's a distance. And at most would be less than or equal to. Okay, so now we're going to do some solving problems. So notice these solving problems look very similar, but notice these first two have an equal sign, and then we have inequalities, and we have some positive 5, we have some negative 5. So let's go ahead and start with the first one. If I say to you, solve for x, notice that the absolute value of 5 is 5, but the absolute value of negative 5 is also 5. So that's why we would say 2 minus 3x equals 5, or 2 minus 3x equals negative 5. It might also help for you to think about what we did up here. So if I say x, the absolute value of x was 3, remember we said x is 3 units from 0 on the number line. And that's why we ended up with the two answers. Okay, so coming back over here, so now we have two equations to solve. So for both equations, we subtract the 2 and divide. So again, I have two answers. So go ahead and pause the video and try B, please. Okay, so did you realize that the absolute value of a number will not be a negative 5? The absolute value of 2x minus 3x must be positive, so this creates no solutions. All right, now we're going to do some with an inequality. So notice C is a less than or equal to, and D is a greater than or equal to. So why don't you write the first step for each? Remember which one was an and, which one was an or. It might help to refer back to the example that we just did. Okay, so if you remember, the less than or equal to was the and the greater than or equal to was the or. And notice if we have less than or equal to 5, for the second statement we wrote greater than or equal to negative 5. So over here we had greater than or equal to 5, for the second statement less than or equal to negative 5. So let's just go back to this example up here. And again, if we had a less than, it meant that x is less than 3 units from 0, and that's why we were able to write x less than 3 and x greater than negative 3. And over here, we had a greater than sign, and so we were actually able to write two statements because it meant x is more than 3 units from 0 on the number line, so x is greater than 3 or x is less than negative 3. Okay, so now we're going to go ahead and solve the inequality. So go ahead and pause the video and go ahead and solve each inequality. All right, so let's see how far you got. I went ahead and added 2 to both sides of the inequality, but we have to remember something before we go any further. For example, if I ask you, is this a true statement? Is 5 less, let's say negative 5. Is negative 5 less than 7? And you would say, yes, that's true. But if you multiply both sides by negative, notice you have to flip the arrow. If I would have left it as a less than, it would not be true. So over here, when I divide both sides of the inequality by a negative 3, you have to remember to flip the arrow. And the same thing over here. So what I would like you to do right now for each problem is go ahead and graph them on the number line and try and write a solution in interval notation. Go ahead and pause the video and give it a try. Oh, sorry, there was a mistake right here. Let's fix that first. Notice that this was a 5 minus 2 is a 3. Sorry about that. So this is a negative 1. Okay, there we go. So go ahead and try and graph. All right, so I went ahead and fixed my mistake here because I was supposed to add 2, or sorry, subtract 2 here and subtract 2 over here. Okay, so now let's just take a look at what's going on. And if you think about kind of putting these problems next to each other, it's kind of interesting. So this is an and. So I would say x is greater than or equal to negative 1 and less than or equal to 7/3. So what you're trying to do is you want the answer to be where it's the intersection, right? So you would want to see, where do you see red and green? Well, I see red and green from negative 1 to 7/3. But over here, I'm saying, okay, let's say this is green. We'll get the red over here. So if I'm saying x less than or equal to negative 1, x greater than or equal to 7/3, so now I'm saying, where do you see red or green? Well, I see red or green, and you would say x is, so you'd say negative infinity to negative 1 and 7/3 to infinity. That's where you see red or green. So notice we have 2 different answers. One was an and one was an or. Okay, so let's go ahead and take a look at the last 2 questions. And again, they just look a little bit tricky. So why don't you pause the video and think about what that would mean if there is a negative number. Okay, so right now I'm guessing that there's probably trouble for E because I'm saying there's an absolute value less than a negative 5. So again, that doesn't sound quite right, but let's just see what would happen if we do this problem similar to the ones that we did in the past. So this is an and. So you would say 2 minus 3x is less than or equal to negative 5, and 2 minus 3x is greater than or equal to 5. Okay, so if we subtract 2, and divide by negative, don't forget to flip the arrow. So now if I want to know, let's see, so less than or equal to negative 1, greater than or equal to 7/3. So if I want to know, where do you see blue and red, notice there's no intersection. There are no numbers that are both greater than or equal to 7/3 and less than the negative 1 at the same time, less than or equal to negative 1 at the same time. So this is no solution. But again, I think we kind of knew that when we first started because we wanted positive numbers less than or equal to negative 5. I can't think of any. Okay, so go ahead and pause the video and go ahead and try F. Okay, so I went ahead and got started. I realized it's a greater than, so that's an or. And I had my 2 statements, 2 minus 3x greater than or equal to negative 5, or 2 minus 3x less than or equal to 5. Now I subtracted 2, and again, I hope I did it correctly this time. Got it. Okay, so now we're going to divide by negative 3. Again, don't forget to flip the arrow. And when we do that, now we're trying to think of numbers that you would say I want numbers less than 7/3. And I'll do a different color, and you could say greater than or equal to negative 1. So go ahead and pause the video. Where do you see blue or green? So again, I think at the beginning when you saw the negative with the absolute value, you thought something strange might happen. And notice that you see blue or green everywhere, all real numbers. So I guess this does make sense though, because you're saying absolute value greater than or equal to negative 5. So that makes sense that all real numbers would satisfy that particular inequality. Okay, so that's it. We are going to stop the video here, and now we're going to move on to section 1.1.